Good day, viewers. I am creating these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated procedures and processes. And today, what I want to do is I want to look at rounding, and in particular, rounding to a given place. And I'm going to use my Dienes or Dienes blocks here to help me with that. And there's a good reason for that. Some people find, it's quite usual for people to introduce rounding using number lines, but I feel like taking a step back and working in the concrete, first of all, can be of real benefit to learners. And that's my experience of working with rounding. Of course, Dinesh is perfectly set up to look at place value and the different place values. So it's a great sort of tool to start looking at accuracy and rounding. So I'm going to need a number to round. So let's say I'm going to round 32 to start with. So I'm going to say to my learners here is build me that 32. Build me the number 32. And for now, we're assuming that the yellow rod is worth 1, or the yellow block is worth 1. So here is my 30, and here is my 2. And now what I'm going to say to my learners is, okay, using only the tens block, how close can you get to recreating that picture? And of course, if I'm only allowed to use the tens block, then in this case, the closest I can get is to this. And so what number have we created that's as close as possible? Well, we've created the number 30. And that's as close I can get, as close as possible I can get to this, only using the tens block. And so what we're saying here is this 32 rounds to 30 if I'm only allowed to use the tens. So the nearest I can get to the value of 32, if I'm only allowed to use the tens block, is to get to 30. And now what's useful about doing something like this is that if I now say, okay, well, imagine that instead of this being the tens, imagine this was worth 1. This whole green block was worth 1. And if pupils have used Dinesh before to explore sort of decimals and things like that and different powers of the base, then there should be no issue with this. We should be used to working with this as the 1 or this as the 1 or even potentially the 100 as the 1. And so if I now redefine this to be the 1, well, then my first number was 3.2. And now the number I've built here is just 3. It's 1, 2, 3. And that's as near as I can get. That's the nearest I can get if I'm only using what is now the ones block, not the tens block. And so we can see that there's this connection here between how I round 32 to the nearest 10 and how I round 3.2 to the nearest 1. We can see that those are connected. And of course, I can, because I'm using Dinesh, I can go sort of to multiple places. So I could look at the number, say 326, and I could build this number again to start with, assuming the yellow block is worth 1. Don't need that many of those. So looking at 326, I nearly built 362. There's 326. And so again, now what I could say is that's not 326 at all, is it? That's 126. Let's try that again, shall we? We're going to need a couple more hundreds before we do that. I'm sure some eagle-eyed viewers were screaming at it there. No, you've not done the... There we are. So now we've got 326. And now I can say, right, well, similar idea. If you've only got 100 blocks, if you're only allowed to use the 100 block, how close can you get to this? Well, of course, if I'm only allowed to use the 100 block, then I can get that close. And so I can build the number 300. And that would be as near as I can get. You have to forgive my handwriting here. It's not easy on the canvas. To the nearest, that's as near as I can get if I'm only using 100 blocks. But what if I'm only allowed to use tens blocks? Well, if I'm only allowed to use tens blocks, then I will need a lot of them, although potentially we could turn around and say, well, if we want to have 10 blocks, let's just use 100 to stand for 10 blocks. Or I could be very literal in this and put tens all the way across here. But if for now, we'll just say that this is 10 tens. So I've got that, and I can get a bit closer now. I can do this, and actually, technically, I can do that because this is closer to having this. This is closer, if you like, to having a complete 10 than it is to having no 10 there. So technically, this, having the extra 10, is closer to what I've got here than having this. And that might take a little bit of sort of working with pupils, but we should be able to see that. And so what we're saying is, if I have 326, if I then go to the nearest tens, if I'm using 10 blocks, what I've got here is I've actually built the number 330. And that's the nearest I can get. And you'll see how I'm playing with the language here, but that's the nearest I can get if I'm only allowed to use the 10 block. And we can sort of adjust that later to the nearest multiple of 10 when we are ready to use number lines, because at some point I would want to move this onto a number line. But this is, I think, a better place to start exploring rounding with pupils. And, similarly, I could now say, well, what do we have? What would it be if the green rod was actually worth 1? Well, then I would have 10, 20, 30. Each of these would be 10. If this is 1, this is 10 times bigger. So I could have 10, 20, 30, 2.6, rounding to 30 or rounding to 32, depending on whether I'm going to use only blue blocks for the 10s or those for the 1s. And I could even say, well, what if the blue block was worth 1? And if the blue block is worth 1, then of course this is 3.26. And then to the nearest 1, that would be 3, and to the nearest tenth, and we can talk about nearest tenth and 1 decimal place, the fact that tenths is the first decimal place, that those two things are synonyms of each other. The nearest tenth or to 1 decimal place mean the same thing, because obviously to 1 decimal place is how it would normally be described. But when I'm first introducing it, I will use language of nearest tenth to begin with, to sort of hold that pattern and then correct that. Or adapt it. It's not correction, but an adaptation later on. Of course, what I've not done yet is I've not explored the big issue that comes with rounding, and that, of course, is when we have a number like this, which for now we're going to call 325. And if I'm only using tens blocks for that, well, then there's a question mark here, isn't there? And there's a question mark as to whether I'm going to put in the extra 10 or not, because both are equal in terms of how close I can get to here. Now, of course, that is a convention. It's a convention, ultimately, that we decide to round the ending in 5 up rather than down. And we could all decide to sort of do that the other way and say, no, if it's a 5, we're going to round down. The closest I can sort of get to a justification of why I would put the extra tens block in there is to actually switch my view slightly and look at counters. And the reason that counters work slightly better for this is because counters are discrete objects, and it makes more sense if we're looking at the numbers in discrete objects why the 5 would round up rather than down. Obviously here I'm using length and area to represent my numbers, area in particular to represent my numbers, and because area is a continuous measure, 5 is exactly at the halfway point between 0 and 10. Whereas if I use my place value counters, if I look at the same numbers, and in particular, if I look at the number 320 to start with, then what I would say to learners is, okay, well, what whole numbers could I build with this as a starting point? And in fact, what I could do here is I could have 320 and put no ones there, or I could have 320 and put a single one there, or I could have 320 and then 2 ones for 2. And I can keep going like this, obviously. I can have 323. And in particular, once I've built all of these, what we'll see is that until I get to 330, so from 300 to 329, in terms of what can follow 320, there are a total of 10 arrangements, of which these are the first 5. And then the second 5 are the ones that have 325, and then similarly 326. I'm not going to bother producing them all now because I've got to the halfway point, but I'd have 326, 327, 328, and 329. I would build all of those if I was building them with learners and I was looking at it with learners. So there's a kind of justification there that if we're starting 320, what can follow it? And I might not use such a big number to start with this because obviously I'd have explored it much lower down. But, just to keep the examples fairly close together, if I'm starting 320 and then what could follow it? Well, what could follow it is no ones, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9 ones. And the first 5 of those are no ones, 2 ones, no ones, 1, 1, 2 ones, 3 ones, 4 ones, and the second 5 of those are 5, 1, 6, 1, 7 ones, 8 ones, 9 ones. And so because it's discrete, that split becomes slightly different, and the line, if you like, that splits them is actually between the 4 and the 5. But I mean, mathematically, that's sort of a kind of almost coincidental kind of thing. I mean, ultimately, it is down to a convention to how we round 325. But I can see that, for numbers between 320, because I could then sort of add a base and stick some 0.1s in there as well, or add a place value, not a base, add an extra place value and put some 0.1s in there as well. So I could be building numbers like 320.0, 320.1 to have the 0 there. Then it kind of sort of shows people why it might make sense to do that. But like I say, ultimately, it is a convention. As always, so that's my short video on looking at rounding and exploring rounding concretely using Dienes and potentially place value counters as well, or Dienes and potentially place value counters as well. As always, there's the bit that comes. I would like to give my big thanks to mathspot.com and its creator, Jonathan Hall, who's produced such a wonderful website. And, it's not only got the virtual manipulatives on it that I've been using to work with these videos and to help make these videos, but there are huge amounts of other things here that if you've not had chance yet to go onto Mathspot and explore, I heartily recommend you do. It will make your life as a teacher easier, and it will make your experience for your students better, I am sure. And of course, if you are interested in using visuals and manipulatives to support your learners in making sense of mathematical concepts and their associated procedures and practices, and of course, why would you be listening to this video if you weren't? Then could I suggest you also check out my video? My website. My website is visiblemaths.co.uk, and amongst the many things you will find there, you will find a link to my book, which is also called Visible Maths. And there's a link on there to the publisher. The publisher is Crown House Publishing, and on that link you can see some sample pages, and if you feel like it would be a useful addition and support with your practice, then you can of course place an order. I will be creating these videos throughout lockdown and potentially beyond. So if there is a particular sort of video, a particular maths concept or process or procedure that you feel like you would want to see using manipulatives or visuals, and how we might make sense of it using manipulatives and visuals, then please do get in touch and I will hopefully get around to creating it for you. Thank you very much for your kind attention today.